Good afternoon, Henry. How are you doing this afternoon?
There you go. I'm doing well. How are you?
I am doing well. It's been a crazy couple of weeks, though. You've been staying inside and staying away from other people.
Yeah. Yep. I have. It's been a kind of a long 2 weeks, I guess.
Oh, it's going to be a lot longer. I think this is going to go on for 2 to 3 months. I mean, if you start, I mean, you're a math person. You start looking at the graphs. We're about 2 weeks behind New York. New York is about 2 weeks before they hit their peak. That means we're 4 weeks from hitting our peak. And then you have to understand that once you hit the peak, you still have to come down, and that's going to take probably as long as it took to get to the top. So I'm thinking June, July. We might be able to go out from there. It's crazy. Now,
Yeah.
did you have a job before this?
I did actually. I'm a karate instructor, and so we pretty much shut down almost immediately
Yep,
as soon as it started to get bad. We
that's right.
went
We talked
about
about this already. Yeah,
two
yeah.
weeks ago. It was
My-
about, yeah, we had like a few classes, and it was like, no, they're doing Zoom, but I had a bit of a cold beforehand, so I haven't done any of those yet. I'm gonna look for a retail job just because those are really in demand right now. So maybe I can
Right, right.
do
However,
something about that.
you want to be careful though. I mean,
Yeah,
you don't
right.
want to be going someplace. I mean, I know I have not been out to too many places, but my brother was saying that he was on the north side of Milwaukee, and he said it looks like there's nothing happening. I mean, he said that all of the stores are still packed with people. It's like, man, there are
Yeah, see,
crazy people out
that's a little bit weird. I mean, I've been to Costco to buy food for my mom
there.
because can really conveniently my not I'm being sarcastic here, but my grandmother had a stroke like the Sunday the outbreak kind of happened.
Oh
So like
boy.
my mom was busy taking care of her for like a whole week, so I had to go and buy food because my dad is a doctor actually. So he was for like the first week or so he was busy with like logistics and just setting up an area
Mm,
like so he's people are
yeah.
so that his clinic can hold people for that stuff. I was actually reading up on it, and I think the virus actually dies out in like 75, 80 degrees Fahrenheit. So it dies out at that point. So we might see a little bit of remission in like summer. Like that's a maybe though. And
Yeah,
which is
I'm looking at this and I'm thinking we're not going to. I'm one of these people that the vaccine shot I think is going to be the only thing that's going to really take care of this is when everybody can get vaccinated. I mean, it happened with the mumps, polio, and all that kind of stuff. I just keep my fingers that they find it quickly because this really stinks. Especially my wife and I have a small business. You can't do anything. I mean, when the doors are shut, I mean, it is nuts. But
yeah, it's really unfortunate for stuff like that.
yeah, it is what it is though. Okay. So both of you guys are taking the AP test this year? Oh, is Caleb's here, isn't he? Caleb,
There
are
we
you
go.
taking the AP test this year?
Can you hear me?
Yep, I can.
Okay, yes, I am. My microphone just took forever to load.
Okay. Have you guys seen the new policy now for the AP test?
I
You're
did,
gonna
I
be
think. Yeah.
okay. It's an at-home online test, and it's only 45 minutes. Now, I have been doing this for a long, long time. I do not know how they're going to test you in 45 minutes online to see what you know or not. So I am at loss on what is going to be on there. Now, I will tell you, I don't know if you guys read that email that I sent. They kind of stopped. They said, okay, since all the schools have been out since March, we're going to just stop right there. However, if you take a look at the way BC is set up, Unit 9 was polar coordinates, um, parametrics, and vectors, right? And then Unit 10 is the sequence and series and all that stuff. Well, they're not testing anything on polar coordinates, vectors, and all that. But they are testing a few things in the sequence series. So we do have to cover that. Now in my AB calculus, they cut out all of the finding area between two curves and volumes of rotation, which usually is the last thing that we study before the AP test. So I don't know why they jumped over Unit 9 and went right to Unit 10, but a lot of it is out of there. I mean, the stuff that we go through the next couple weeks, it says it's going to be on the AP test, so that's all I'm covering. I mean, there's a lot of sequence and series stuff that we will not be covering this year, because if you took a look at what they expect you to know, half of it's gone. I mean, half of the sequence and series is out of there, which is kind of cool because some of it is pretty intense with finding the interval of convergence and stuff like that. So I will only be showing you guys what they say is going to be on the test, okay? All right. So let's go to last week or not last week, the week before, because we're dealing with, we had spring in there. We were talking about, we were just starting sequence and series, right? We were talking about writing terms and finding the sum and terms of different sequences and the sum of geometric ones. So in this review here, it says write the first 5 terms of a sequence. Now, in order to write the first 5 terms, all you do is you plug in, if it's given to you in a recursive formula, all you have to do is write down the first 5 terms. So I just plug in 1 here, so that's 4 times 1 minus 3, that would give me 1. If I put 2 in here, that's 8 minus 3, which would give me 5. If I put 3 in here, that would be, what is that, 9, 13, 17, dot, 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 dot. Okay, now, this is not a recursive formula. This is what is called a recursive formula. In a recursive formula, they have to give you the first term. So they gave me the first term, so that's 3. And then they tell you how to find the next term. So k plus 1, so the second term, if I put 1 in here, that would give me a sub 2. Well, how do you find a sub 2? You just plug in 2 times a sub 1 minus 2 times a sub 1 minus 1. Well, a sub 1, they already told us, was 3. So the second term would be 2 times 3 minus 1, which would be 4. Now, if I wanted to find the next term, I would put 4 in here. So that would be 2 times 4 minus 1, which is 3, so that would be 6. If I wanted to find the next term, I put 6 in here. 6 minus 1 is 5. 2 times 5 is 10. Dot, 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 dot. This is called a recursive formula. This is called an explicit formula. An explicit formula, you just plug in the numbers 1, 2, 3, 4 to get your next terms. In a recursive formula, you have to use the term directly in front to get the next term. That's why they have to give you a sub 1, because if they don't give you a sub 1, where do you start? Okay, does that make sense? I don't think we went over recursive formulas last week.
I have a question. So it'd be like the Fibonacci sequence is a recursive sequence. So like it'd be so you start with, it'd be 0. You start with 0 and it's AK plus.
Yeah, because you always know that it's going to be a recursive formula when it's written this way, where it's like a sub 1 is equal to, let's try a different one. A sub 1 is equal to 5, and then a sub k plus 1 is equal to, let's say, 2k plus 4. Okay, so then, oops, I'm sorry, it can't be k. It would be 2 a sub k plus 1, or a sub k plus 4. So in this problem, a sub 1 is 5, so then if I wanted to find a sub 2, which I just put 1 in here, 1 plus 1 is 2, so that would be, I put 1 in here, so that's 2 times a sub 1. Well, a sub 1 is 5, so 2 times 5 is 10. 10 plus 4 is 14. So that would be a sub 2. If I wanted to find a sub 3, I would just put 14 in here. So this would be 2 times 14, which is 28. 28 plus 4 is 32. And then I would just keep going like that to get my next terms. Okay? And I don't know why we didn't talk about recursive last week. I must have been out of it. Which does happen. but you rarely will ever see a recursive formula on an AP test. All right. Then we also found the sum of convergent series, but we only talked about geometric series, right? So in order to find the sum of a convergent series, first thing we have to do is we have to make sure that the R value is less than 1. So do you guys remember what the formula is to find the sum of a convergent series? What should that be? Guys forgot already? Yeah. The formula for finding the sum of a geometric sequence, oh no, my marker went blank here, is a sub 1 over 1 minus r. Well, a sub 1, you really have to look at this. So if I put 0 in here, my first term is going to be 5, isn't it? If I put 1 in here, that's going to be what? 10 would be my second term. If I put 3 in here, no, I'm sorry. If I put 1 in here, yeah, I get 10/3. If I put 2 in here, I get 4/9, so 20/9, I think. Okay. Caleb, your did not work. Why don't you give it a shot? Okay, so you. All right. Hopefully your mic
Should be working now, right? Good.
Yeah, it is good.
Okay, thanks.
So in this problem, I would just put 5 in here for a sub 1. And then 1 minus r, well, my r value is 2/3. So this is going to be 5 over 1/3, which is, Henry said already, 15. And that is where that sum would converge. How about the second one? What is the sum of the second geometric sequence? And I always like plugging numbers in to see what my first term is, my second term, and all that. So if I put 0 in here, my first term is 1, isn't it? And then my second term, if I put 2 in here, negative 1/5 to the second power is 1 over 25. So if I was going to do this, my first term is 1, and then 1 minus negative 1/5. So boom, boom. So I've got 1 over, what is that going to be, 5/5? No. This is 1/5, right? So that would be 6/5. So 1 over 6/5, which is 5/6. So you guys are correct. Very nice. Then it says determine the convergence or divergence of the sequence with the given nth term. If the sequence converges, find its limit. Okay, well, this comes back to limits, right? We're just going to go the limit as n approaches infinity, 5 over n plus 2. Well, that's small over big, so that's 0. So my function is going to converge to 0. And this one is going to be, if you put infinity in here, 5 over infinity, that's 0, so 8. Is that right? Converges to 8. All right, you already had it before I did it. All right. Oh, these are some more geometric ones. However, both of these diverge, don't they? If I'm looking at it right, 5 over 2, that's more than 1, diverges. 1.5, that's more than 1, diverges. So both of these sums are going to diverge. All right, new stuff for this week. Nth term test for divergence, okay? So we already talked about geometric sequences, find out if they diverge or converge, okay? Very easy to tell. All you have to do is look at the R to find out if they're going to converge or diverge. Now this is called the nth term test for divergence. It says if the limit of the nth term of a convergent series, okay, the sum as n equals 1 to infinity a sub n converges, then the limit as n approaches infinity of a sub n has to be 0. Okay, so the nth term test for divergence. Okay, so now this is what we already know. So now the nth term test for divergence states that if the limit of the nth term of a series does not converge to 0, the series must diverge. Okay, so here's the rule. The limit as n approaches infinity of a sub n does not equal 0, then the sum of the series is going to diverge. So let's try an example. They already did the example. It says for the series, the sum from n equals 0 to infinity of 2n you have, okay, so then we find the limit as n approaches infinity, 2n is equal to infinity. That's not 0. So the limit of the nth term is not 0 and the series diverges. And most people could just look at that and tell that's going to diverge. How about this one? This one is a little bit tougher. Okay, this one takes a little bit more work. What I'm going to do is I'm going to simplify this thing first, because what I want to do is I want to find the limit. I'm going to rewrite this as a sub n. Then I'm going to find the limit as n approaches infinity of a sub n. And if that is not 0, then the sum of this diverges. So what I did in this problem is I tried to factor. I did n factorial over, and then I pulled an n factorial out of here, which is kind of an interesting way to factor, right? So I'm going to factor out an n factorial. Well, what do I have left if I factor out an n factorial? Don't I have 2 plus 1 over n factorial? Yeah, exactly. So now it looks like I can cross this off. So my a sub n is equal to 1 over 2 plus 1 over n factorial. So I want to find the limit as n. So I want to find the limit of this as n goes to infinity. What is the limit of this as n goes to infinity? 1/2. That is, oh, not infinity. It should be 1/2 because I have 1 over 2 plus 1 over n factorial. Well, if I put infinity in here, this is going to be a super huge number, but I've got a small over a big, so this is going to be 1 over 2 plus 0, which is 1 over 2. So it does not equal 0, so it must diverge. Here's another one. This one happens to be 0, so that means I know, well, this one's 0. Because the limit of nth term is 0, the nth term test for divergence does not apply, and you cannot draw any conclusions of convergence or divergence. All right, now this is the new stuff that they say is going to be on the AP test, p-series. You're going to have to be able to find if a p-series converges or diverges. Super, super easy. And when I saw that on the list, that it's like, oh, p-series, that's one of the easier things to do. And harmonic series. All right, use properties of p-series and harmonic series. A second type of series has a simple arithmetic test for convergence or divergence. A series of the form, okay, so this is the form 1 over n to the p. That is the form that we're looking for. This is called a p-series. And all we have to do in order to figure out if it converges or diverges is to look at the p-value. Okay? Is a p-series where p is a positive constant, for p equals 1, the series is. So if p is equal to 1, then we have what is called our harmonic series. Okay, so if P equals 1, so if I have 1 over n, you could really put a P here, or you could put a 1 there. So that's 1 over 1, 1 over 2, 1 over 3. This is called our harmonic series when the p-value is 1. So let's take a couple examples here. All right, so here's the theorem. It says, this is the p-series convergence theorem. It says, if p is greater than 1, it converges. So if p is greater than 1, it converges. And it diverges if p is greater than 0 and less than or equal to 1. So a harmonic series diverges because a harmonic series, p is equal to 1, right? So diverges if it's between 0 and 1, and it converges if p is greater than 1. So let's take some examples of what they're going to give us. Oh no, this looks like it's all messed up. Why did my numbers? Okay, well, that's fine. Okay, so if this is my series, 1 over n, p is equal to 1, that means it diverges. Here's another one, 1 over n squared. Well, guess what? My p-value is 2. That's greater than 1. This function converges. That is how easy this week is. You cannot. Not yet. And that's where convergence series, and they don't ask us to find out where it converges. All this does is it just tells me, does the function converge or diverge? Does not tell me anything about where it converges, or obviously if it diverges, it's just going to be infinity. But it does not tell us where it converges. It just tells us if it does converge or diverge. That is all it tells us. So here's a couple examples, and you're gonna kind of chuckle how easy these are. Is the series convergent or divergent? Well, I've got 5 here as my p-value. Converges. In this one, this one's a little bit trickier. But can I write it like this? 1 over 2 to the 1/2 plus 1 over 3 to the 1/2 plus 1 over 4 to the 1/2. Now it makes it easy to see that my p-value is 1/2. This function diverges because my p-value is between 0 and 1. How about the next one? Converges or diverges? That is a 6, yes. That is a 6. Hard to read. Sorry about that. That is a 6, though. It's convergent, right? So these are like the p-series, super simple to be able to tell if it converges or diverges. How about these two? Converge or diverge? Okay. How about the first one? Diverge, right? Because I could rewrite this as 1 over n to the 1/4. Well, that's between 0 and 1. That diverges. How about the second one? Diverge also. N to the 0.9999. That's a divergent series. Now, there are a lot of other tests for convergent and divergent. However, and I had to take out about 20 slides here this week because the AP test doesn't have it on there. For convergent and divergent, it just had the p-series and harmonic series. Next week, we're going to be dealing with the alternating series when it goes from positive to negative, the positive to negative, and we'll be finding the convergence or divergence of that. So a lot of the stuff that BC Calculus used to have in it is not there anymore. So it's probably one of the shortest sessions I've ever had with BC Calculus. That is it for this week. This week you're only dealing with the P-series and harmonic series. Any questions on that? All right. Well, that is it for this week. Yeah, it really is. However, did I start putting review material in there? I gotta check the pace chart for this week. Because I wanted to start reviewing too, since everything is. Oh yeah, so there is some graphs of like which you guys will see. It'll be pretty easy. There's some derivative graphs, for example, like you'll see there'll be a problem like this, where this will be g prime of x, and it'll ask you where is the function increasing, where is it decreasing, where is it concave up, where is it concave down. The practice AP test is part of your grade, yes. However, if you don't have time to do it right now, Caleb, you don't have to. You can wait until after the AP testing is over. And that's what, usually the last 3 weeks of school, there is no new material. So if you are really struggling with your other classes and it's like, oh, I've got this stuff, I know how to do this, it's perfectly fine. You can do it after the AP test is over, because that 3 weeks that we don't have anything to do, you can just work on getting all your other stuff made up. Okay? All right, any other questions for this week? All right, you guys have a great one. Stay safe and keep apart. Bye.